Hello everyone, I Dr. Souvik Patra, faculty in the Department of Civil Engineering, Swami Vivekananda Institute of Science and Technology, Govindpur. Welcome you all again to the lecture series on Energy Science and Engineering for the third semester. In this lecture, I will cover basically the energy and its relation with sustainability and the environment. As we know that energy is the fundamental to all forms of life and human civilizations, and whatever the activity we take in our daily life, from our charging our mobile phones to running electronic appliances, or lighting our homes, running large scale industries, growing food and food processing unit, transporting goods from through railway to operate port. So in everywhere we require energy. But we human, as we produce energy, we also at the same time we produce some kind of emissions. Basically, these are your greenhouse gas emissions in the environment, and these emissions causes environmental deteriorations. It also deteriorates the life expectancy of human being or any habitat present in the environment. So we need to focus on a planet which is sustainable. That's mean which is basically safe, secure, and clean for our future generations. So if we talk about the energy, so energy are in different form. So if we summarize the forms of energy, these are basically your mechanical energy, which is basically potential energy, and the kinetic energy. We have thermal energy, which is stored internal energy due to molecular motion, chemical energy. We have also electrical energy, nuclear energy, and radiant or solar energy. Now, we can broadly classify the sources of energy from we harness the electricity or the power. We can classify them in mainly two categories. One is renewable energy and another one is your non-renewable energy. We call it renewable energy. That's mean the source of the energy is infinite. That it will not finish, or we cannot take all the sources within a human lifetime. So these energies are called basically renewable energy. And the example of renewable energy are your solar power, wind power, hydropower, geothermal power, biomass power. Also, we have wave energy, tidal energy, nuclear energy, like this. And we call non-renewable energy are those energy uh, whose resource is finite. That means it can uh, finish within a limited time, such as coal, oil, natural gas. So these resources are basically formed are called as a fossil fuels, and the amount of fossil fuels present in the earth is limited, so we can enjoy the generation of electricity or power from these fossil fuels until the source is available. So these are finite resources, and these resources are called as a non-renewable resources, and the electricity or the power we generate from these kind of resources is known as your non-renewable energy. Now, another important definition we require for our energy science, that is your energy conversion and efficiency. Conversion basically defines the transformation of energy from one form to another form. That's mean from mechanical energy to like electrical energy, or from thermal energy to electrical energy. And the efficiency is defined as the ratio of the output energy to the total input energy. That means suppose I am transforming energy, suppose chemical energy to your electrical energy, and if the chemical energy is 100 joule as input, and we are getting output as 90 joule, so the efficiency eta will be your 90 by 100 multiplied by 100, so it will be 90% efficient, and we can say that the system is 90% efficient. That's mean due to the conversion or, transferring the energy, we have lost 10% of the energy. So that is your energy conversion and efficiency. Another term that is very much important for our civil engineer, that is energy systems, and where we civil engineer plays a very important role. Now, energy system is known as the set of technologies, process, and infrastructure used to produce, convert, transmit, and consume energy. That means suppose I have a power plant here. Suppose a thermal power plant I have. Okay, from here I am generating electricity. Okay, and before that, we have a source that is known as coal, and we are burning the coal in a thermal power plant. From this, we are getting electricity energy. electric energy, and this energy is transmitted through transmission tower to our household or home. So all these stages are together known as your energy system. So from resources to the production to the infrastructure, transmission and the consume. So here the source is coal, the infrastructure is the thermal power plant, and the transmission is the transmission tower through which we are transmitting the electricity, and end consumer where at home we are enjoying the electricity. So the main component of an energy system can be classified in four stages. First is the energy sources, that is the raw forms of energy. Like here it is coal, sometimes it may be fossil fuel, or it may be your uranium for nuclear power plant, or sometimes it may be for non-renewable energy resources like wind, solar, etc. Conversion technologies, a device or an infrastructure, or you can say a power plant which convert primary energy into useful energy. Like in hydropower plant, we basically convert the kinetic motion of the water uh, through turbine, we transform it into electricity. Similarly, we have a solar panel, that is a technology. We are capturing the radiation of the sun, and we are generating electricity through the solar cells. So that is the conversion technology. After that, after generating the electricity, we need to store it, or we need to transfer to the end consumer. So therefore here we require transmission and distribution. So we will create, you have seen that there are lots of transmission towers are there connected to electrical wires. So these are the transmission and distribution network, and that deliver energy to the users, or we get it in our home. And the end use applications are energy utilization in transport, industry, agriculture, and our homes. If you noticed here, at every stages there is a very important role the civil engineering can play. Suppose for the raw sources, suppose we need to often coal. Here we need to go to mine coal, or if it's a oil, we need to extract oil from seabed or any kind of oil zone, oil reserve. So that is here we need to build the infrastructure which is which support the mining operation or the oil extraction operation. Here civil engineers plays a very important role. Then the conversion technologies. Here we need to install the device. Suppose I have a solar panel, but these solar panels would be installed on a foundation. So this foundation will be designed by your civil engineer. Similarly, if we convert the coal or burning the coal into thermal energy, then converting it into the electrical energy, in this case also, we need an infrastructure, and that infrastructure is known as your thermal power plant. And here the thermal power plant can be will be constructed by civil engineer. So the conversion technologies also there is a role of civil engineer. After the conversion of the energy or the generation of the electricity, we need to transmit it to the power grid or to our household. So that's why we have seen there are large scale of transmission towers are there, and these transmission towers are situated on foundation. Also it is a truss kind of structure or lattice structure, you can say. So these structures are also developed by civil engineers. And at the end use applications where you are enjoying the industry, agriculture, homes, here also civil engineer plays an important role. So you can say that in an energy system, at every stages from sources to the end use applications, everywhere there is an important role of a civil engineer which need to be played. And when it is a time for sustainable development, so we need to go for renewable energy and new technologies, new kind of innovations, and new kind of infrastructure. Now, if you now let see or evaluate the global energy scenario, you can say that the present day the whole society is basically dependent on the energy that is produced from the fossil fuels, from our moving car to generation of electricity. So mostly it is dependent on fossil fuels, and fossil fuels are basically your coal, natural gas, and your oil. And the 80% of global energy is generated from this fossil fuel. But the disadvantage of this fossil fuel is that it can emit harmful gases like CO2, SO2, nitrogen oxides, etc. So these can create or it can deteriorate our air quality. Also, it can increase the temperature. These all these gases, CO2, uh, HO2, NOx, these all are basically your greenhouse gases, basically GHG, greenhouse gases. These gases basically increase the temperature of the environment. So we need to follow an approach, or we need to mitigate this problem, and we can do it by adapting renewable energy sources. These are basically your wind, solar, wave energy, some kind of type tidal energy, biomass energy, or you can say geothermal energy. So that's why the renewable energy is rapidly growing, but it is unevenly distributed. It is unevenly distributed because the infrastructure or the conversion of the energy through renewable sources is in a development stage, and it is costlier rather than the well developed energy harnessing from your fossil fuels. So only few developed countries and the countries which are basically technologically or scientifically advanced, they can adapt this kind of renewable energy sources. But the most of the countries which are basically third world country like your African nations, they have to depend on the fossil fuels mainly. So there is an uneven distribution of the energy also. But the earth is one, and we all are living in the same earth. So the renewable energy, the technology should be evenly distributed. And also developing nations face challenges of energy access and affordability for the same reason. Now, if we judge the key issues which are the global energy is uh, facing right now, is the rising demand due to the population and industrialization. As you know, simply if we take the example of our country, we are developing, our GDP growth is higher. So to maintain the GDP growth and the economic activity, we need industrialization to run port, transportation infrastructure. So all the in all the field, we require a high we require a high energy, and dependence on the finite fossil fuels is limited, because for this purpose we have to depend on other country. It also creating environmental hazards and environmental degradation and greenhouse gas emissions. So we need to mitigate that. We need to decrease our dependency on fossil fuels and increase the use of your renewable energy sources. And also we need to reduce the degradation of the environment for a sustainable future, and the greenhouse gas emission, which will reduce the temperature of the climate, because these greenhouse gases are primarily responsible for the increase of the temperature of the environment. So if we check the global scenario presently, that is basically 6% is basically from your nuclear energy we generate, 24% from coal, 23% from natural gas, 38% from oil, and the 9% is renewable energy. So if you see that 15% is only contributed from your you can say clean energy technologies, and the mostly 80% is basically dependent on your fossil fuels. Now for a sustainable future, we have to shift the dependency from this fossil fuel to nuclear power or the renewable energy sources. Although I should mention here that nuclear power plant also have some disadvantage due to the waste, the radioactive waste generation. I will discuss in a module 3 when we talk about the energy infrastructure for uh, nuclear power plant. Now, if we take all these things in the global scenario, that as we 80% are is electricity is generating from your fossil fuel, so there are some environmental consequences are there. So now let's discuss the consequences. The first one is the air pollution, and we breathe, we require fresh oxygen to maintain our metabolism or to sustain life on Earth. But the burning coal and oil releases basically sulfur dioxide, nitrogen oxides, and carbon monoxide and particulate matters, particularly PM 2.5 and PM 10. These causing basically smog and respiratory disease. So here it is impacting as well as the environment, the human health, and also decreasing the life expectancy. That means if someone is earlier for a clean environment, if someone is living his or her life for 100 years, now it is 60 or 65 years. Similarly, the industrial waste and oil spills contaminate the water bodies. Thermal power plant discharge heated water, affecting aquatic systems. That means, suppose if you have a water body and here you have a thermal power plant, so lots of heats are generated. Even in iron industry, to cool down the iron, we generally use your water. So this heat water is back to the your pond or any kind of storage. So in heated water, all this contaminated water, no aquatic animal or aquatic plants or anything cannot be developed. Similarly, mining, drilling, and construction of energy facilities disturb natural habitats and degrade the land. And if the land is degraded in future, it will not be possible to do farming on such kind of degraded or deteriorated land. And another important aspect of your greenhouse gas is that the climate change. Due to the fossil fuel combustions, increase carbon dioxide concentration, intensifying the greenhouse effect. That's mean it is increasing the temperature of the climate and it leads to the global warming, the melting glaciers, which leads to the rising of the sea level and extreme weather conditions. That's mean earlier we have a six seasons and it is coming in a pattern, but the pattern is now disrupted due to the change in the climate. You may have seen that now in the Sahara Desert, there is some green vegetables have been grown. So the climate is changing as well as the overall pattern of the habitat life on the earth is also changing. And now, the last environmental impact of this kind of harnessing energy is that the waste generation. And the most profound is nuclear power produce radioactive waste, and it basically emit radioactive radiations, which is very much harmful for our not our life only, any kind of life on Earth. Also, from thermal power plant, lots of coal ashes are generated, which can mix with the air and deteriorate the quality of the air and other disposal challenges. That's mean we need to go for a proper waste management so that this kind of waste which basically generated from or generates from your power plant or any kind of energy harnessing infrastructure should be minimized. So that's why we come to a concept that's called a sustainability because all the burning of the fossil fuels and harnessing energy from this kind of fossil fuels is generating lots of environmental hazards. So the United Nations and all the leading countries of the world they come together and they develop a concept that is known as your sustainability. And if we want to define sustainability, it basically refers to the meeting the needs of the present without compromising the ability of future generation to meet their own needs. That's mean, suppose I have here a green forest is here present now, but due to environmental hazards, it may be lost. So the upcoming futures, the 50, 60 years, which the generation who are coming, they cannot enjoy this scenic beauty. They cannot enjoy the fresh air. So we are destroying the environment for them. But at the same time, at present, to growth or to maintain economic activity, we need the energy. So we need to adapt such technologies or the approach in which we can harness the energy. At the same time, we will not harm the environment. That is without compromising the ability of future generations. So that is basically known as your sustainability. And there are mainly three pillars are there for sustainability. The first one is your environmental, second one is your economic, and the third one is your societal or social. Now, environmental goal is that to protect natural resources and ecosystem because we are also a part of the environment and the ecosystem. So you also know the food chain, food web, all this. So we all are connected. So if one life is disrupted, then another will be affected. So we need to protect the environment, and we can protect the environment by going for a sustainable approach, and that is by reducing releasing of your harmful gases in the environment. And the economic aspect is that thus it support the long-term economic growth without harming the environment. That's why we need to adapt some clean technology which will help to the economic growth, but at the same time it will not harm the environment. And the societal or the social issue is that the ensure equity, health, and well-being of all communities. That's mean the every people of the earth, that is first world countries, third world country, everyone should have the same right to breathe fresh air. Everyone have the same right to maintain a good health, good food, good educations, all these things. So this is basically social aspect. So if we represent this here, suppose if this is your environmental aspect of your sustainable development, if this is your economic aspect, and if this is your societal aspect, so all three together can create a sustainable future. So if we maintain all the three, then we'll get a sustainable future. So our sustainable energy system basically use clean, efficient and renewable sources while minimizing pollution and waste. Like suppose we can go for energy resources like no, renewable energy resources. We can opt for your smart bulbs, sensors, which can minimize the uh, loss of energy and we can conserve energy. So by this kind of adapting this kind of approach, we can go for a sustainable future. So this is the end of our second lecture of module 1. In the next lecture, we will start your module 2. Thank you and hope to see you again in the next lecture.